Hello everyone. Today we are in another lesson of the recursion course of DSA whose name is Tower of Hanoi. It's a very, you can say, generic question which is asked in certain types of interviews. And if you know this algorithm, it's pretty easy for you to code for it. Let's see what's Tower of Hanoi and how do we solve it using recursion. So, what is Tower of Hanoi? Interesting question. It's basically a mathematical puzzle where we have three rods, that is A, B, and C, and you have n discs. Don't worry, we are gonna see what are discs and what are rods in the next slide. What happened initially is all the discs are stacked in decreasing value of their diameter. So some discs are of a certain diameter, some are less than it, some are more than it. So the smallest discs should be placed on the top and they are on the rod. What's the objective of this puzzle? You have to move the entire stack to another rod, suppose C, and you have to obey certain rules. You can move only one disc at a time, and each move will consist of taking the upper disc from one of the stacks and placing on the top of the another stack. So what you're going to do is, if you're taking a disc from stack A or from rod A, you can put it in rod C. The upper disc only can be moved in one attempt to the another rod. So a single disc will be moved. That should be the uppermost disc. And you cannot place any disc on the top of a smaller disc. So let's see in a diagrammatic manner. Here we are. So here you can see that we have three rods A, B, and C, and the discs are arranged in increasing order of the diameter. Like the uppermost disc is the smallest, and the lowermost disc is the having the largest diameter. Your job is you have to place it in the same manner in another rod. Simple. Your idea is to use the helper rod to reach the destination using recursion. So what's the pattern for this? Shift n minus 1 disc from A to B using C. Shift the last disc from A to C. Then shift n minus 1 disc from B to C using B. You can see this in the example. Here you have the three discs in the first picture. In the first step, what we did was the pink disc was moved to C. In the second step, the white disc was moved to B. In the third step, the pink disc from C was moved to B. In the fourth step, the blue disc from A is moved to C. In the fifth step, you can see that the pink disc is moved to A. In the sixth step, the white disc is moved from B to C. In the seventh and the final step, the pink disc from A is moved to C. So this is what this algorithm states. So what are the steps that we followed? You have to create a function called Tower of Hanoi, where you have to pass the input parameter as n, that is current number of disk from rod to rod, and the auxiliary or the helper node rod. You have to make a function call for the n minus 1th disk, then print the current disk along with from rod and to rod. Again, you have to make the function call, the n minus 1th disk. These steps are pretty simple if you look at this diagram. Don't try to mug up the steps. Just see the diagram, visualize it, and then you can be able to write the algorithm bit. So your coding perspective, the time complexity will be big O of 2 to the power n, where there are two possibilities for every disk. So 2 cross 2 cross 2 cross 2. So n times it gives 2 to the power n. Your auxiliary space will be big O of n, and the function is called stack space. Now let's move to the coding platform, and then now let's code for it. So we have here what's Tower of Hanoi dot Python. Okay, let's create a function def Tower of Hanoi in from rod to rod and your auxiliary rod. Okay, if your n is double equal to 0, return Tower of Hanoi, return. In the next, we are gonna write Tower of Hanoi. Let's recursively call it n minus 1 from rod auxiliary rod. Okay. Then okay, here done. So everything is good to go? Yes. Rod, two rod, and auxiliary rod. So here we have again the rod, auxiliary rod, and two rod. Okay. Then let's print the statement here. In the move your disk in Tower of Hanoi. Let's write the parameters again. N minus 1 ox rod, the auxiliary rod, 2 rod, and again the bottom. Now let's write the driver code here. If your name is double equal to main, what are we supposed to do? N is equal to 3. Like we have given the number of rods is 3. Then your tower of Hanoi, let's write the parameters. N, comma, let's write the names. A, B, C. C, auxiliary rod. The destination rod is B. Let's save it. And now let's run. So see, these are the steps that you got as your answer. So first you have to move this one from rod A to C, then two from A to B, then one from C to B, and continue. So I hope this was clear. It was pretty simple. You understood the Tower of Hanoi problem, the solution of it, how to code it, how to make it optimized. So with this, I would end this session. I'd wrap up here. And I hope that you guys keep coding and keep learning.